So yeah, we know how to read from files and write to files. So writing to files, that was OF stream, output file stream. Reading from files was IF stream, input file stream. And we did some cool stuff with that. You made hopefully a cool example program, right? I just want to kind of give you some more intuition about how files work. I just have a bunch of fun examples for the day. Okay, so when you're reading from a file, I kind of want you to think of it like you're opening up that file in like Google Docs or Microsoft Word or something. You know how like when you start typing, like there's always a cursor as like where you type is going to be? That same kind of idea is happening when you're reading from a file. So like there's a tiny little cursor that's tracking where you are in the file. So like you open up a file, that will start the cursor. Like you open up the file for once, it'll start the cursor right here, and that's why you read the first word, kind of, if that makes sense. And then like if you start getting stuff, you start reading strings, which reads single words out of the deal. Like it'll read the string into S, right? What does this line do? It reads a single word, and it will move the cursor so that you don't reread that word. Like, I've moved foo into the S variable. See kind of what's going to go on. Then you're ready to read the next one. And then IFS, reading in a new string, it'll skip over white space and read in the next word. Then it's red bar, right? Skip it over. Read in, skip over the white space, read in the next string, baz. And then one last time, skip over the white space, read in blah. That's kind of what's going to happen, all right? That's kind of how you think about it as you're reading from the file. That's why when you read multiple times, right, you're not getting the same word because it's moving that cursor. Question? I just started, yeah. I started already. Right there. All right. Let's see here. So yeah, that's how I want you to think of it as you're reading. So surprisingly, the second you read that blah, it doesn't actually think you're at the end of the file yet, which is a little weird to think about. So let me show you like how you can mess up. It's very easy to mess up. Let's check for EOF, and we'll just keep reading a word if it's false. Like I'm gonna show you that you need to try to read once more and have it fail to notice that you're at the end of the file. Like doing it this many times, exactly 4 times, doesn't actually know that it's at the end of the file yet. Let me show that to you. Whee! I'll make a new file called, well, first of all, I need a file to read, so let's do that. Let's make that exact file, that sample-file. Let's steal it from here. I want this exact file, please. Sample-file.txt. Boop. So there it is. And then let's do an example where I read that and notice the end of the file. So I'll call it eof.cpp. All right, so I'm going to read that file, so remember what it looks like. That one. I'd like to use an input file stream. So I'll include fstream, and I'll open the file, fstream ifs. Actually, can I copy most of this code as well? I'm going to do my best here. That's going to have to change. I just want to read in four words, right? 4 words. Do it a few times. 1, 2, 3, 4 times. And then this needs to be normal, non-curly quotes. And that should work. There we go. So here I am reading those 4 strings, right? I've read foo, bar, baz, and blah. I'll read all 4 of them. And surprisingly, if you output ifs.eof right now, do you think ifs that you're at the end of the file? It should be, right? Because it just read blah. The cursor should be right there after. But surprisingly, watch. False. It does not think it's at the end of the file. Ooh. So that's a little unfortunate. Okay, so you never have to worry about this problem, right? If you do it this way, you do it the cool way. While you can read from ifs into a string variable, this will always run the body as long as it works and stop when it stops working. So, like, this is another reason to always do it this way, I guess. But yeah, when you try to read this last word, it doesn't actually notice the end of the file. So it's really got the cursor kind of like right here. Here's the last word, and here's the little cursor. You have to try to read once more to notice the end of the file. It's like another special character after the end. All right? So you have to try to read past the end of the file. And once you do that, your read just failed because you're doing it in a line like this again. Like you have to try once more, ifs read into s, and it will fail, right? Because you've read the last word already. So this will not do anything. This line will not do anything except notice the end of the file. All right? You might accidentally think that like there were 2 blahs in the file because s has not changed. This line is not going to do anything other than notice the end of the file. All right? That's what's about to happen. Dun, dun, dun. So notices the end of the file and the read fails. All right, so that's what's about to happen. And now if I say IFS, read into see if I can get EOF out of the deal, it's going to be true. It will finally be true. So yes, it was in the file, but this line did nothing at the same time, other than notice the end of the file. So if I output what S is right now, what is S? This line didn't get anything new. It didn't like make it blank or something. It just didn't actually set S again. So do you see how it would be very easy for you to accidentally think that you read blah twice? Because S will be blah here, after this one, and after this one. See the problem? So just keep that in mind. Every time you read, it should be, if you're going to do it this way, it's got to be read, then check if the read worked. Check EOF right after the read. If it is now true, that read did nothing, and you should stop. All right, so that's the moral of this story. So yeah, just be super careful about accidentally like thinking that your input variable got modified when you just noticed the end of the file, because it did not. Okay, so that's just a common error that I see. But again, if you do it this way, read in a loop like this, it will always work and you'll never have issues. So another reason to do it that way always. Okay, so I just have a bunch of fun examples for the day of random file stuff. So I'm going to take our favorite song, Let It Go from Frozen, and we're going to translate it. All right. So here's the goal. We're gonna read the lyrics of this song. Here, I've got them ready for us. So here they are, the lyrics of Let It Go, and we're going to read a word at a time and translate that word, because I know we speak more than just English in this class, a lot of us. So let's see here. Won't that be fun? I'm excited. So yeah, we're going to read the lyrics and translate some of the words, and we're also going to have to deal with white space in a second. Okay? So let me get this started. Are there any questions before I get started? Yeah. I'm going to translate, like, we can translate snow to Spanish. We can translate white to some other language that we speak in the class. I'll ask you guys what you speak, and then we'll deal with that in a second. But yeah, I think it'll be fun because we get to learn, like, what are we fluent in this class. So I'll make a new file called, I guess I'll call it translate.cpp. We'll just translate one word at a time. And so here's kind of the game. We've got to open up the file for sure. So I'll do fstream. Let's open up the file called Let It Go lyrics.txt, named exactly that. So open that up. ifstream, ifs, let it go lyrics.txt. There it is. And remember to close it at the end. I guess that close. I may have forgotten that in the last program. Excuse me. There's that. And yeah, here's kind of what I want to do. I want to read a word at a time, and I'll do it the bad way. All right, maybe I'll use ifs.eof. Actually, I think that's more work than it needs to be. So let's just do it the normal way. String word, and I'll say while I can read from ifs into the word variable and it worked, do this with the word variable. All right, just more practice doing the right thing. So here's what I'll do. I'll do like cout, take that word and translate it. I'll have some sort of translation function, and then like output a space after it or something after we've translated it. Does that make sense? So that'll be what we do. We're reading a word at a time. We're going to translate it into some new word, potentially, if we know how. So this is called translate. It'll take a string S, and we're not going to change the string S. We're going to give back a different translated version. So we can take it by constant reference, and we need to give back a new string, right? Give back a brand new translated string. And let's say just at the start that we don't know how to translate anything. So like, let's just return back the original one. Just like call it a deal, right? So we're just not actually translating anything right now. We're just giving back the original word. But that's a good start. All right, so here, let's run this. And so here we go. We've got the entire text being printed out, and it's a little bit ugly because it's kind of like lost the whole stanzas kind of stuff going on. It's like we've translated every white space into just a normal space, so that's not as cool. We'll fix that later. But yeah, let's write this translation function. So what languages do we speak in this class? Some of us definitely speak Spanish, right? So like let's translate snow to Spanish snow, nieve. So let's do that. So if S is equal to snow, return Spanish snow, nieve, right? That'll be fine. And then like otherwise, if we don't know how to translate something, we'll just return the original string and hope that the other person can figure it out still. But yeah, what are some other languages that we speak in this class? Anybody else? Spanish? Nothing? Are we scared? What did I do last time? We got We can translate mountain. That's another. Nouns are easy, right? What do we speak? None of us? What? Tagalog, yeah, let's translate that to mountain to Tagalog. Do you know it off the top of your head, how to spell it? All right, let's do it. Let's go translate.google.com. Let's translate mountain into Tagalog. I want to show you something cool anyway. English to Tagalog. It should be here. Is it really not? Oh, really? Oh, I see. Interesting. Let's do mountain. So apparently it's that. Is it not going to say it? It should pronounce it for us. Where's my volume? I don't actually know where the volume is. I'm so sorry. Let's see. I want to know how it's pronounced. It's probably a bundok or something. But I need to know. Let's do it to my normal computer speakers. Let me just turn it up a lot. That's apparently, you don't pronounce the K. Interesting. I like it. So else if, right? Else if my string is mountain, we will return bundok. Something like that. Cool. And then just for fun, let's do some language that's not having Latin characters. Let's do like Japanese or Chinese or something. Let's see here. What's another good noun? Like, I guess we can do tonight. We can do, what is that? Is it an adverb? I don't even know. I don't even know. Maybe it's its own class of stuff. But let's translate tonight to like Japanese or something. That's already in here. So Japanese is konya. Cool. But we can take the entire characters, just like that, tonight. Else if. This is tonight. This is something I didn't, you might not know that you can do in C++. Just be like, return, boop, konya. Just the non-English characters. And that will totally print. As long as you put it between quotes, it's fine. You can't like name a variable this, but if it's between quotes, it's happy. It's okay. It will reproduce it. All right. So yeah, there's my translation function. I think that's not too bad, right? So let's watch it happen. So I translate now, and I scroll up. Watch. The nieve glows white on the bundok konya. Beautiful. Where did it go? And so yeah, now we're translating stuff. Isn't that fun? And now let's work on the white space. All right, let's fix this. So this is disgusting. It should be nice and like new lines and like individual stanzas. So like there's one new line there and another new line here, right? So let's preserve that existing white space rather than just like eating it up like we were doing before and just like turning it all into a space. So let's fix that. All right, so we still want to translate the word, but let's preserve the original white space. Let's not like reproduce it as just a normal space. Okay, so here's the goal. We're going to take the word that we just read, and then we're going to preserve any white space after this word. Preserve. All the white space could be tabs, could be spaces, could be new lines, a couple of new lines. Preserve all the white space, whatever the characters were after this word, and the secret is going to be with these two functions. We may have you guys used cin.get already? Has your book taught you that? That's something that exists on any iStream, but let's go to the ifstream documentation. I have it open here. Cool. Already open from last time. So let's go. It's called your ifstream object, ifs.get. You could say ifs.get or ifs.peek. Oops. And it will give you back characters. All right, so ifs.get reads in a brand new character, gives you back a character. For some reason, it's giving it back to you as an int. Let's not worry about that right now. And then also peek also reads the next character after your cursor. All right, but there's one difference between the two. They're both going to read the next character after your cursor. One's going to move it, and the other's not going to. So here is, let's say that this is your file. This is your IFS. Here's the word that you're on right now, and here is your cursor. Can I move that one? No, let me put the cursor over here for a second so it can become movable. So there's my cursor. It's on the B. If you say IFS right now, IFS dot get, let's see here. You say ifs.get, it will give you back the B, and also move the cursor, like you're eating up that character, that B character. Oh man, it's not letting me move it anymore. Never mind. So it'll get the character and then also move the cursor. All right, so now it's there. Ready to read the L next. ifs.peek does the same thing, but just like puts its head up and like looks at the character. It does not eat it up. All right, it does not move the cursor. So this will give you back the L character, but it will not move the cursor. You just peek at it. All right. Whereas get would have eaten it up. All right, doesn't move the cursor. So that's how we're going to preserve white space. We're going to peek ahead in our file. We're going to be like, all right, we just read the peek ahead to the next character. Is it a white space character? Yes, it is. If so, eat it up and preserve it as well. Okay, so that's what we're going to do. And then when we get to like the new lines, a couple of new lines at the end of the stanza, for example, we're going to peek ahead, see the new line, preserve it, peek ahead again, see the new line again, and preserve it, and also eat it up and get ready for the next normal non-white space character. Okay, so this makes sense with the example. So let me show that to you. So I need CC type to know what's white space or not. Don't I? I need to be calling is space all the time. Let's see here. And then also, I probably should have included the string library because I'm using strings. It's included by somebody else, but it's better to do it yourself. All right, so here's the game now. So I want to preserve all the white space after this word. So if I can peek ahead, so while peeking ahead, ifs.peeking ahead is a white space character. So while is space is true for ifs.peek. Does that make sense? So while ifs.peek, the character ahead of me is a space, I would like to do the following. I'd like to eat it up so that we can look at the next character with a dot get. Because if it's not white space, I don't want to get it. Right? Don't eat it up. But now I can. The char, next char, whatever it was, it's a white space character. I can say ifs.get. That's going to be the same thing that peek gave me. But now I've moved the cursor. All right. And then I want to take whatever that was and preserve it. So output that same character. That white space character. So I'll just say cout whatever that character was. It was some sort of white space character. And then as long as that's true, keep going. Because maybe there's two new lines in a row, like here, right? One new line, another new line. So we've got to peek ahead twice and eat it up twice to get to this T. Does that make sense? So then the cursor would end up like right there. You can see my tiny console cursor. So that's what's about to happen, all right? And then, yeah, as long as that's true, keep going. The second it becomes false, we're good to come back to this condition and read another normal word, right? We're at a normal non-space character at that point. Okay. Any questions about that? Bless you. So that's gonna do the proper white space preservation. Yes. That's right. Because if you only used peek, you would never like move the cursor. Technically, I guess that's a great question actually. So this IFS would have eaten it up for you, yes, but you need to look ahead multiple times sometimes. And the reason that is because of like here, there's two new lines, so you can't like peek ahead two characters from now. That's impossible. So you have to peek, eat that one up, then peek at the next one after. Does that make sense? Yeah, that's going to be why we need to use both peek and get, because we want to definitely not eat up the T once we get here. Got to just peek ahead, see the T, and stop. Right? That's going to be the goal. Nice, good question. Any others before I show you this hopefully working? Crossing our fingers. All right, let's see it. Oh yeah, look at that. The nieve glows white on the bundo konya. And then we got the preservation of the multiple new lines and everything, and the final stanza is all there. We're good to go. Beautiful. So that is a good file to study, I think. Nice. Okay, I just have a few examples today, so let's see. What's my next one? Let's do our own version of the copy command. Have we used that before on the terminal? Maybe we have, maybe we haven't. But CP is standing for copy. It's a terminal command that copies one file into another. If you say CP, the name of the file, and then you can copy it into another copy of the file called file2. That's what it does. CP file1, file2 copies file1 into file2. Whatever those names are. So it kind of does this. So we're going to make our own version of that program. We're going to make our own / our own copy, and give it file1 the name and file2 the name, right? And we're going to have it read from this file and write to this file name. Yeah. That's what we're going to do. So first of all, we have to use command line arguments. That's pretty nice. We're going to get those names in where. The name of the program is an argv of 0, so that means the first file name is an argv of 1, and the second file name is going to be an argv of 2. See that? So that's how we're going to get those. And we're going to need one iStream to read from this file that exists, right? And to write with an OF stream, into this file too that may not already exist, right? And let's just do it a character at a time. So one IF stream reading, one OF stream writing, and let's do a bunch of reading. Right? We'll read a character, preserve that character in the output file. We'll say ifs.get to read a single character. We know that already now. And then we'll do the opposite of get in an OF stream is called put. That writes a single character to the output. Okay, so that is over here in, oh wait, not there. I would like to go to OF stream, please. And so that's the exact opposite of get is called put. Where is that? Oh gosh, it's called output, so that the put is everywhere. There it is, put. It takes a single character and writes it into the output file stream. Okay. So yeah, that's what we're going to do. Just read a single character, write a single character. And we'll call that, it's hard to pronounce, cp.cpp. Why not? For copy. So we need, let's see, I'm going to need strings, and I'm going to need fstream for file stuff. So all right, I need command line arguments. Somebody's calling me like this, so I need argc and argv. Int argc char star argv bracket bracket. All right, and let's just assume that the user did it right, so we don't have to. We could be checking argc if we were good programmers, but let's just be lazy. And then let's get the input file name and the output file name in string variables. So argv of 1 is the input file name, argv of 2 is the output file name to copy into. So let's see, string input file name is argv of 1, and then argv of 2 will be the output file name. Okay, so now I've got them, and I need to open up an IF stream to read from the input, right? IFS, read from the input file name, and an OF stream to read from the output file name, or write to, sorry, the output file name. And then once we're done with all our fancy work, we have to close the two of them. It's always good practice. So we'll say ifs.close and ofs.close. And then now, in between, we're going to read a single character of the first file, the ifs, and then output a single character to the output file. So while, forever, until we're done, until we notice that we're at the end of the file, we'll finally do it the .eof way. Let's read a character. Read a character from ifs. And then if we're going to do it this way with the OF, we have to check, did that read succeed after we tried? Because it will only tell us that we hit the end after we try reading to the end. All right, so let's make sure, before we use that character, make sure we got a valid character before we rate it. Okay, that's the goal there. So, and then if we're still good, if we're still good to write this character, let's put the character into OFS if it was valid. All right. So let's see here. How do you read a character from IFS? It's just ifs.get. You can read that into a char variable, char c, I guess. And then we need to check, did this read work? Or did we try to just read past the end of the file? If so, C is garbage right now. All right, so let's check. So if, you can do just if IFS is good, that's fine. Which means like if not IFS is true, means it was false, which means it's not good. But you can also just check EOF. If ifs.eof is true, we hit the end of the file, right? And so we should break out of this loop because this character was past the end. We're done now. Okay. So let's see. If not IFS would also work because IFS gives back true if it's good, and so if we negate the true, right, if it becomes false, we check for that. That's also another way. Okay. So if we're still here, it was valid, right? So we'll just put that character into OFS if we're still in here. So that's going to be OFS.put, that single character. We'll write the character, right? So that's the main loop. Open up both files, get one character out, make sure it was valid, stop if we're at the end of the file, and put that one character back into the file and keep on playing that game until you've gotten to the end of the input file. And then just close both of them. So that's, let's see, can I show you everything? Yes, there, just like that. So yeah, you want to try it? Let's copy this sample file.txt. We'll say /rcp sample file.txt into, what do I want to call it? I'll call it sample file copy.txt. Boop. So just like that. And we see no output on our end, but it should have made, there it is, sample file copy. And the first file, oh gosh, okay, let me turn down my volume real quick before I forget. What was that before? So the old sample file had that, and then the new sample file copy, should also have that same text. Cool. So we did it. We did the copying. And you can look at that in Vim too if you want. Sample file copy and sample file, they're the same. We did it. Are there any questions about why this is correctly going to copy those two files, one into the other? Yeah, cat is going to print the contents of a file to the terminal screen, so you don't have to like open it in Vim or something. Just faster way to see the file if you know that it's short. Yeah, cat is short for concatenate. I love that they called it cat, though. Yeah, any other questions about this program? All right, that's a fun one. Let's see, what else do you need to know? Let's talk about something called a string stream. It's a new type. It's a fun word. So a string stream lives in the following library. It's called S-stream. So I have to include this new thing. But a string stream is kind of like in between CIN and COUT, and then also IF stream and OF stream. It's like a combination of all of them. It's really weird. It's like your own personal CIN and COUT, okay? Which is weird to think about. But they live in S-stream. Here they are. Let me show you how to look up more information about them. There it is, S-stream. And we're going to use string streams, capable of doing both input and output. They're both I streams and O streams at the same time. Crazy. And so if you make a string stream object, you can give it stuff, and you can pull stuff out of it at the same time, which is really cool. All right, so yeah, it's like your own personal CIN and COUT. What it's doing secretly is it's going to build up like an inner string for you, and you can get that out eventually. So you make a string stream like this, string stream, give it a name. I'll just call it like SS or something for string stream. And then what you can do is like it makes a blank, essentially it makes a blank string. Think of it like a blank file or a blank string that's temporary. And you can give it stuff, or you can get stuff out. So let's first give it stuff. Let's be like SS, give it 100. It's like you're printing into it through COUT or as if it were a file. And that will like put it in there as a string. Okay. And then you can give it new line. Then that'll break the line. You can give it another thing like 200. Give it whatever you want. 200. And so there's the file or the string that it's being built, having built up. It's building up a string. And then you can come back around and extract stuff out of it. You can be like, all right, int x, read from the string stream into x. It's like your own personal CIN and COUT at the same time. So like the cursor starts here, right? And then we just read into an x variable. So it's going to read an int's worth of stuff and put the cursor right there. And then x will hold 100 after that. Isn't that cool? So you can do that. And then also, this whole thing that you're building up is a string. So deep down, it has a string inside of it. You can say ss.stir. Give me that string out. And it will just give you back the string 100, new line 200. Because that's what you put in. All right. So it's a cool way of like building up stuff. So here's like an example. Does the constructor have a good example? Let's see. Yeah, so like here they are, 100 space 200. And then they're reading the 100 and the 200 out again. All right. So that's a cool example. And then you can always get the string that you built up by .stir. You can also use that to set the contents as well if you want. So you can say ss.stir. That gives you the entire string that you've built up inside of your string stream. Right, so let me just show you a program with all that as an example. But this may be of use to you one day. And you can see how similar it is to everything. Right, files and CIN and COUT. So I'm going to include S-stream instead of F-stream. And we'll do string SS. I'll give it some stuff. SS, give it 100. And it's always going to convert it into a string and hold it deep down as a string secretly. So if I just give it 100, so now the secret string inside of SS is 100. Does that kind of make sense? And then if I give it something else, if I give it a new line, bless you, now it holds 100 new line. If I give it 200, now it holds 100 new line 200, the string. All right, so that's the goal. And so you've built up that string. You can also get stuff out that you've put in. So you can be like int x, read from ss into x, starts the cursor at the beginning. So it'll read the 100 because that's the first int, and move the cursor to be ready to read the 200 if you wanted to. So see out my x, and so that'll print the 100, and get it back as an int again. So it's doing some conversion. So that's just going to print 100 right now. And if you want, you can always get out the whole string that you put in. You can be like cout ss.stir, and now we'll give the whole string back that you've built up, even though you might have read some of it already. It keeps it around though. It doesn't actually get rid of it when you read from it. So it's still the full 100 new line 200. Okay? So that's why we see that exact output. Does that make enough sense? Just like your own personal cin and cout. It's useful, yeah. What? Oh yeah. Because I read from it. It's like it was just this one int, right? I only wanted to read an int. And so there's only one. The first int is all that gets read because we asked for one int. Does that make sense? If you asked for like read a line, call get line on it technically, then it would read more than that. But yeah, it's just because I asked for an int, just like as if this were like an IF stream or even CN. Yeah. Good question though. Let's see here. Any other questions about this? So this actually, historical note, this used to be the only way that you can convert from an int to a string. Does that make sense? Because then, like, you put it into a string stream and get out the stir. Now we have the toString function, of course, but this used to be the only way you could do that. That's the backwards way. Yeah, that's kind of the reverse direction. So A to I takes a string, gives you back an int, and this is another way technically to do that. Yeah, but we did have A to I back then. That was from the C library. But yeah, this is another way to do some things that you already know how to do. So now you have options if you like this way better. All right. Yeah, good questions. Any other questions? I think I have a fun example for you guys to try now. So what I'm going to do is I'm going to give you all of this lecture 20 code. So if you can go to our Canvas and go to one of the code from class pages, just like today's lecture isn't up yet, of course, but go to any other code from class page. I am going to, you should now see a lecture 20 folder for us. All right. And inside of that folder, there is one file I haven't talked about yet. It is a list of the, I think it's like the 1,000 most common, almost 1,000 most common Swedish words. Okay, each on a single line. So we're going to be using that file. So please, like, take it off of the code from class. Just copy and paste it onto the terminal into a brand new file for yourself. And here is your job. I'll give you plenty of time to do it. We got time. What's that? What name is it? It's in the code from class for lecture 20. So go to any code from class link and it'll be in a lecture 20 folder. What's that? I promise it's there. Here, let me show you how. So go to any other lecture, or at the very tippy top we have, right, just the normal code from class link. Let's see here. Dun, dun, dun. 40. I promise it's there. Unless I lost internet connection. There it is, lecture 20. So just refresh your page. Maybe you got there too quick, maybe too fast. And then here it is. Let it go lyrics. One way to easily copy it is to click this raw button. You can just do a Control-A, Control-C. That'll work. But yeah, there it is. Here's this entire file, and here's your job. I'm sure you've been, or at least have heard of IKEA, right? They have really weird product names that just kind of sound like they slapped two Swedish words right next to each other. Some of them are funny words if you try to transliterate them. But here is your job. I've given you a bunch of popular Swedish words. Right? I've given you a giant list of them. What I'd like you to do is use that list to generate random IKEA product names. All right? And some of them might sound convincing. So you got the file now. What I'd like you to do is read all those words. Here's like a good algorithm. Read all those words into a vector of strings, right? A, B, whatever these words are. Read them all into a giant vector. And I'd like you to go to 2 random spots of that vector, right? Maybe pick out, I don't know, index 1 first. That's a random index. Go to index 3 next. Take those 2 words and shove them next to each other, BD. And that's your random IKEA product name. Does that make sense? So some of them might actually sound cool. So feel free to share them if you'd like. Put them on Discord or shout them out. But I'm going to do this too. But I think this is a really good example of reading from files in a cool way, in a normal way, and like doing something useful with it. So please generate some hot IKEA product names for fall 2024. All right? And let me know if you have questions. Read all the words in that file. You can look at, because I gave you the translate file. That one was reading all the words, wasn't it? So you can hook into that and use that. I've also given you some other examples of reading all of something out of a file. So you got a few examples to go and look at and copy that code. Swedish words next to each other. And maybe they're already the name of the Swedish, already the name of the IKEA product. We want to be doing this on the server if we're humoring me along. We need the random library right from CSCI. You'll have to seed it. So you have to include seed time as well to get to those random indices too. C time because it's from the C library. Yeah. Need to include vector because I want you to use vectors. You'll just keep on pushing back each word you find in the file until it's over. C time, yeah. C time will give you the current time. So we're going to call SRAN with the it's SRAN times 0 is the fancy. What's that? SRAN, yeah. SRAN and RAND are also in CSTDLib. So you need that one for randomness. If you want it different every time, you also need the C time. Seed it with the current time. I'll give you like 3 more minutes to play around, and then I'll do it. You can keep working on it though, once the timer goes, but you can race me. I can't all caps. Maybe I should have been capital Very good. All right, so keep on going if you'd like, but now you can race me because I'll do it too. And explain my ideas as we do it. So I'm reading all this file. Apparently mine is called this. You could have pasted yours in any file name, but remember your file name. Mine is called capital Swedish words. So I'll call this ikea.cpp. So I need to read from a file, fstream, into a vector of strings. And I need to use randomness to go to random indices. So I need cstdlib, and I need ctime to see the random number generator. So I think that's all the libraries that I need. Let's try it. All right, so let's see here. See the random number generator. sran times 0. Then I would like to open up the file, ifstream, ifs, from swedishwords.txt was the name that I used for my file. Making sure to close it when I'm done using it. And yeah, what do I need to do with these words? Read them into a vector. So I'll make a vector of strings called words, and then I want to read every word into words in the file. Say while I can read from ifs into a new word variable, which I'll make right here. Well, I can read from ifs into one word, and it worked. What do I want to do with that word? Push it back to words. Does that make sense? And that's all I need the file for, right? The second I can close the file after that. I've used it for its purpose. I've got this vector of words now. Does that part make sense? I've got every word in the file in this vector. And now I would like to go to 2 random indices of this vector. 2 random indices from its start, which is 0, right, all the way to its size minus 1. So let's figure this out. Get 2 random words out of the file, which is now the vector, I guess, out of the vector. All right, which is like getting 2 words out of the file. So let's say string word 1 equals question mark. So I need to go somewhere, right? I need to go somewhere in this words vector, words.at some random index, right? Some random index where everyone is possible between 0 and size minus 1. Actually, an easy way to do that is to call rand, of course, and shrink it down by mod words.size. Do you see how that's going to work? Because what are your valid remainder values after dividing by words.size? It's either 0, winning cleanly, all the way up to size minus 1. That's exactly right. You see that? That will give you a random index into that vector. And everyone is possible. Does that make sense? That's going to be the secret. That's how you get to a random index between 0 and size minus 1. You just mod by words.size. Like if the size was 10, you did mod by 10 on your random number, you get a number between 0 and 9, because those are valid remainders after dividing by 10. Can't get any bigger than that, because otherwise it would have gone one more, right? It would have gone in one more time. And then there's word 2. We can do the same thing one more time to get a second word. And let's just shove them together. See out, word 1, and then word 2 without any spaces in between. And that should do it. Does that make sense? That's the secret. So let's see, I don't know if I can show you this all at once. Can I show you both parts of this, maybe? Well, there's reading all the words, and here is like going to random indices. You can't really see both, so I guess that's a bad idea. But let's run it. And bam, I get Blommaden. I'm not even going to pretend that I know how to pronounce Swedish words. But like that, maybe we would buy that, right? That looks like it's convincing. This is probably how they generate their product names. Look at that. Absolutely. Wouldn't you want to spend $300 on one of those? I think that's fun. All right, I hope you continue working on it yourself and then check your answer with mine. Okay? So yeah, any questions about this program and why it's going to do what it needs to do? Going to random indices in a vector, and the vector is filled with the words of a file. I think it's a fun idea. All right, so now I think I have one last example, and this might be the coolest example I could ever give throughout the entire semester, so I'm excited to give it to you. It's all downhill from here. So it's called images. I'm going to read and modify an image file, because what is it but a file, all right? I'm going to modify a special easy CSCI 40 kind of file format, though. It's called a PPM file, and I'll go to this page so you can see what the file type looks like. It's very simple. It's a text file that like corresponds to, like, you give every pixel in an image, and then we can mess with this file and change an image. Won't that be fun? So, okay. Before we go there, I need to talk about images just to make sure we're all on the same page. Like, maybe we're not familiar with how like images are displayed inside of computers or how they're stored. So first of all, do we understand that every picture on the internet, every image file is made up of a bunch of pixels, a bunch of squares, and each square is tiny, but it's all just one color. Right? So if you zoom in on your screen, you take a magnifying glass, everything is just one color wide, right? One pixel. There's one color. Just making them small makes it look like they're a bunch of colors, right? It's multicolored. So they're a bunch of square pixels of a single color, and each color is represented in what's called, usually, it's called the RGB format, right? Most colors on a computer are represented in that way, and that format looks like this. You give 3 integers between 0 and 255. So really, they could have been chars or something. So 3 bytes, essentially. 3 numbers between 0 and 255 that correspond to how much red is in this color, how much green is in this color, and how much blue is in this color. And yeah, that's called the RGB color system, which kind of makes sense, I hope. And it is an additive color system. So it's like light. It's not like paint where if you mix all the paints, it's like black. If you mix all of light, it becomes a white, right? So all of each color, 255 red, 255 green, 255 blue, makes the color white in RGB. And the absence of all of those, 0, 0, 0, makes black. And I think you can imagine like 255, 0, 0, all red, no green, no blue, makes pure red. Okay, that kind of makes sense. So that's how colors are going to be represented. And yeah, in general, they're just some amount of red, some amount of green, some amount of blue. If you follow this pattern, though, you kind of understand, like, if the reds, greens, and blues are all equal to each other, you can kind of extrapolate from these ideas. That actually is going to make a perfectly neutral shade of gray. So like 16, 16, 16, it's close to black, but not quite black. It's a dark gray, okay? Purely neutral. And then 95, 95, 95 is like a lighter shade of gray, but perfectly neutral still. So like you have technically, if you count black and white, you have 256 shades of purely neutral gray in RGB color land. And so now, let's talk about the PPM image format. All right, it's just a file type, just like JPEG, just like PNG, whatever. It's a file type that stores images, and it's very easy for us CSCI 40 students to work with. All right, it's just a bunch of text. It's not like binary numbers or anything. So what you do is, here's what the file type looks like. All right, you just give like the RGB values, like separated by spaces, and some extra stuff at the start. as just text. Okay, so like here's what a ppm image looks like. You can have little comments even like Python comments. They start with a number sign, but like forget about those. So every ppm image looks like this. You say p3 at the start. It's like telling you what kind of file type it is. And then you give the width and height of your image. So this example image. It's a very small image, 3 by 2 pixels. And then you give like how wide the colors are. We want to do full RGB up all the way to 255. So you give 255. So like these 3 lines, P3, these guys, width and height, 255. You need that in every image file. And then you start giving in row order, left to right, top to bottom, all of the pixels in this image. So here's red, here's green, here's blue, and you see those in order. And then the next one is yellow. Apparently, red plus green makes yellow. And then here's all white, all black, and like that's your image. And so we can do that. We can convert any JPEG into this, and I have done so, and we can mess with these. Okay, so here is, let's see, where do I want to be? Make a new folder, or a new window here. Here is a picture in ppm image format of my cat when he was a kitten. I do believe I'm able to open this with a program. No, it's called Irfan View, which I thought I installed. There it is. Oh, I didn't install it. All right, I'm going to install it right now. But like the default image, image viewer in Windows cannot display this. It's a special kind of image type. So here, I'm installing this program. I don't want a desktop shortcut. You can give me start menu, though, stuff. Do whatever you want. Sure. There is the program, and it's just able to look at this weird esoteric image format. It better, at least. Are you unhappy still? There you go. Open it. Open it now. There it is. So here's just a picture of my cat when he was a kitten. He's laying on my running clothes. And so there's a lot of colors. Like there's pure red almost, pure blue. So that's why I chose this picture. And then what we're going to do to this picture of my cat is, can I zoom in? There it is. We are going to translate it into grayscale. That's why I told you what shades of gray are. All right, here's what we're going to do. We're going to convert this image to grayscale. And all it is, right, it's a ppm image. So it looks like this secretly. Where's my terminal? So here it is, cat.ppm. P3, it's this much wide by this much tall, 255, then you start giving pixels in order. So this is 38, 8, 24, 41. These are a couple pixels, all right? And so I'm going to convert this colorful image, into grayscale, all right? So just using shades of gray only. And one way to make an image grayscale is to convert its pixels to the closest all equal RGB values, all right? And one way to determine the closest is just to take the average. So like if you're given this pixel RGB, whatever it was, you can find like the average lightness by computing R plus G plus B all over 3, right? Integer division, I guess. And that's like a number that's like an average amount of lightness, because like some of them, if they're closer to 55, they're like lighter than others. It'll like average it out. And then you just replace this original pixel that was RGB with average, average, average. Right? Because if you've repeated it, it becomes a shade of gray, and it's like the closest shade of gray that kind of averages together the lightness of all the other individual colored channels, we say. All right? So that's what I'm going to do. I'm going to read this file, preserve the first 3 lines, because we're not changing the size or anything, and then read reds, greens, and blues all day long until I hit the end of the file. And mess with them and write back to a new file, right? The average 3 times. Does the game plan make sense? There's a great example of files, I think. Right? Probably the coolest example because it's visual that I can give in this class. All right, so let's take this, save it over there so we can see it, and let's make a new program. We'll call it gray.cpp. So I need, let's see, fstring. I'm going to read a file. I want to use strings. That'll make things easier for me. So I'd like to, let's see here. I like to read this file and output a new file that's the grayscale equivalent of it. So let's do it this way. So we'll do ifstream, ifs, read the original file, cat.ppm, just a text file. And then I'll do an ofstream, ofs, and write to a brand new file called like cat gray or something. All right. Of course, I want to close them both when I'm done. And then in between, we do all our work. So we want to preserve these first 3 lines. So the P3, whatever these are, the first 3 lines, keep them all. All right. So I can just do this way. So I keep the same first 3 lines in the output image. Right? I can just do it like this. I can be like string line. I can use getLine on IFS. So I can say getLine, not from CN, but from IFS, into the line variable. And like, there's my first line. That was the P3 part, whatever it was. Put that into OFS. That'll preserve it, these lines. Does that make sense? I'll preserve the first line, the second line, the third line. You have to add the endl back in because getLine does not include that in the string. So here I am preserving the first 3 lines of the file, whatever they were. Just get the line and shove it right back into OFS. Get it out of IFS, shove it into OFS. Those 3 lines are the same now. And now I have a bunch of pixel data, a bunch of RGB land, right, stuff. So now I want to repeatedly read those colors. Repeatedly read RGB values and modify them. Writing to the new file, of course. So, there's my images. So now we're on these lines, right? Until the end of the file, it's like this. There's a lot of lines. There's a lot of pixels. It's a very inefficient file format, but that's okay. There's the last pixel. Keep on going. It's always RGB until the end of the file now. All right? So now I'll make int RGB. I'll make some variables to hold the reds, the greens, and the blue parts because I'm going to read them all separately. And now here's how I'm going to read, right? While I can read from IFS into red and green after some white space and blue after some white space. We've seen that work before, right? You can read multiple things all at once. That's fine. And then, all right, I've got a value in RGB. That's my pixel right now. Yes?
What's the end line for the cat pixel?
What is that?
Like the very last cat pixel.
That's just the very last. It's just one last pixel.
I copied and pasted it. I didn't know if it
all of it. Oh, nice. Okay, yes, that's going to be a... I respect it. Yeah, that's a long copy process for sure. Nice. So yeah, you can convert your own pictures into ppms if you'd like. There's online converters for that I can help you with. But this is fun to get this working and to try it on your own images. I think that's really cool. And to play around with it in a different way. Like swap the color channels or something. Change the reds to the greens and vice versa. So we're just going to do averaging. So now I've got RGB values and I can average them. So I want to convert to grayscale. And add it to the output image. Okay, that's what I want to do. So what's the average of this now? Int average value, average RGB value is R plus G plus B over 3, right? So there we go. And now that's my average value. I just want to duplicate that 3 times because I'm writing red space green space blue, and it's just that same one 3 times because that's what it means to be gray. It's the closest grayscale value for one sense of closest. There's competing ways to take the grayscale value out. All right. So OFS, give it the average 3 times, space separated. Average, space, average, space, average one more time, and then a new line. Okay. So that, my friends, should do it. There. And then I close both files, and that's it. This is going to take a while, but that's the trick. All right, so let's compile and run this. Gray. So yeah, let's explain it because this is not an efficient file format. It's like several megabytes. This file. Yeah, it's 5 megabytes, and so it has to write 5 more megabytes, a character at a time, essentially, few numbers at a time. But like, yeah, let's go back. Let's talk about it. So what I did is I opened up both files, right? I preserved the first 3 lines. Oops. There's the first 3 lines preserved with these getLine calls and shoving them back into OFS. And then I'm just reading one line at a time, essentially, because it's read one int, then another int after white space, then another int after white space. That's always going to be RGB, right? We're never skipping any. It's always 3 things per line. And just keep doing that. As long as you can keep doing that and it worked, right? It'll return true and let you run the body with those new values, and that's a new pixel. So you're going to compute the average value and then duplicate that 3 times, because that's like one way of making the closest brightness value as a grayscale value, okay? The closest brightness value of this pixel that we just read, okay? And yeah, it's working away. We didn't actually have it print anything out. We could have had it print out like, okay, I've processed 10% of the file so far. It is not the fastest program in the world because it's a very long file. I don't even want to know. We're talking millions of characters, right? So almost 500,000 lines even. So it's going to take a while to run, but at the end of the day, it will have produced a brand new picture. There it goes. Finally gave me my terminal back. So let's look at it. Let's see what happens. So here's the let me mess with how I'm doing this. Here's the program. There's like the major part of the conversion. Let's split it here, and of course it messed that up. So there's like the conversion part. Let's do caps.ppm here, and split it, and here's the gray version. Let's open up the gray version. There it is. So we preserved. Here's the original on the left, new one on the right. Preserved the first 3 lines, cool. And then now we took this one, computed the average. Apparently that was 23. Duplicated it 3 times. Took this next pixel, computed the average. Apparently that was 28. Apparently this one was also 28, which is fun to think about. It makes sense. Like it took one from here and one from here or something. I don't know, but that seems counterintuitive. But we have integer division to thank for that, I guess. And so then the next one was 23. That was the average of those guys. And we just did that until the end of the file. Okay, all 504,500 lines. All the way down to here, and it's all a bunch of grayscale values. And now, moment of truth. Here's the original. I would like it to like notice both files, but I think I have to just open this one like that. Here's the original. There's the grayscale version. Look at it. It's beautiful, and you can see like the relative brightness is more or less intact. Yeah, everything has become gray. And I guess the blue is lighter than the red technically, a little bit, which is hard to see with my own human eyes, but the colors don't lie. But yeah, I think that's all that I wanted to say. So any questions about this fun little example? Yeah, both of you. What? This is just a normal Windows program. Is that what you mean? Yeah, so I'm just opening, this is a new program called like Irfan or however you pronounce it. Is that what you're asking? Well, I opened up, this is Vim still. I opened it up in Vim again. This is the file, because it's just a text file, so I can open it up in Vim as well. Does that make sense? Yeah. Another question?
Is there a way to make it more efficient, or is that?
Oh gosh, my best guess is wait until CSCI 45, and then you learn about a special kind of assembly instruction that can read a bunch of things at once. That's one way to do it. What are your thoughts, Declan? How could you make this faster? Just SIMD operations scream, yeah, like that seems right, like the right way to do it to me. What else? I really don't know. Yeah, I think maybe the easiest thing to do right now would be to use like, don't do it one int at a time. Just like read the whole file into a string, because then it's in RAM by then, and then put it into a string stream essentially. Put the entire file into a string stream, and then you can read things out very, very quickly. It'll do the conversion a lot faster, and then write the file to another string stream rather than the actual file, so that you're building up the whole thing, and rather than writing like a single int at a time, you're going to just write the entire answer from RAM all at once. That would take much less time. So I think that would save, would at least take off half the amount of time probably, or more. That'd probably be the easiest thing to do. Like have it all at once in RAM, do it all in one go, copying and like processing. Yeah, good thoughts. Any other questions about this? So, like, try this. I can help you get your own personal files in ppm format if you'd like, and you can mess with it in some way that you care about. That's a great way to learn. So, yeah, I think that's what I wanted to say about that, and that brings us to the end of our slides, which is exciting. So you're all experts with files now. I think what I wanted to do was nothing, right? Do attendance, if you forgot to do attendance by now. I'll leave it open for one more minute. And yeah, I think it was just the lecture for the day. Let's confirm that. There it is. Yeah, so I'll give you a new lab, but we'll deal with that on Thursday. So yeah, the rest of the time is all yours to work.